So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is Trionic Array Part 1. So you are given an integer array nums of length n, and array is trionic if there exist indices such that p is greater than 0, q is greater than p, and q is less than n minus 1, such that the nums of 0 to p is strictly increasing, the nums of p to q is strictly decreasing, and nums of q up till n minus 1 is again strictly increasing. Return true if nums is trionic, otherwise return false. So this is what the question is saying. So the question is saying that you are given a nums array. You need to find whether in this nums array there exists this kind of pattern or not. So the first part should be increasing, the second part should be decreasing, and the third part should again be strictly increasing. So this is what the question is saying. So let us see this first example. So the first example is this 1 3 5 4 2 6. So you can see 1 3 5 it is strictly increasing. From 5 to 4 it is, from 5 4 2 it is strictly decreasing, and from 2 to 6 again it is strictly increasing. So it is strictly increasing, then strictly decreasing, and then again strictly decreasing. So it fulfills the property of trionic array. So we are returning true. So this is what the question is saying, and this is pretty much easy problem. Just we need to implement what it is said, and since it is an easy question and we can just use the brute force approach. We will also see the optimized approach, but yeah, brute force will also work, and this is just implementation. So whatever the question has asked, we just need to implement that. So let us see the brute force solution. So in the brute force solution, we are iterating over all possible values of p and q, and we are just checking whether from 0 to p it is strictly increasing or not, and from p to q it is strictly decreasing or not, and again from q to n minus 1 it is again strictly increasing or not. So we have created two functions, is increasing and is decreasing, which will check whether this particular part from L to R it is strictly increasing or not. Is decreasing, it will check whether up this particular part from L to R it is strictly decreasing or not. So this is what it is doing. So we are iterating over all the possible value of p and q, so it will take O of n square, and for checking is strictly increasing and strictly is decreasing, it will again take O of n. So at final time complexity in the brute force approach will become O of n cube, but we can again optimize this to O of n also. So how we can optimize this to O of n? So instead of iterating over all the possible value of p and q, what we need to have three parts, right? Strictly increasing, then strictly decreasing, and then strictly increasing. So why not just keep on iterating till where we get the strictly increasing part? We will stop here, we will mark, okay, this is the index where which we have got the first increasing part end. Now what we will do, we will check, we will continue our iteration from this index up till we will get a strictly decreasing part. So till this point we will say, okay, this is the part where we will get the strictly decreasing part. Then again from here we will continue our iteration and we will check till where we will get the strictly increasing part. So we will mark, okay, till this point we get the strictly increasing part. So this will be the second strictly increasing part, and this will be the first strictly increasing part. In the end we can check for the condition whether this is greater than 0 and this is not equal to this particular value increasing 1 and all of that. So conditions we can just check it in the end, and according to that we can return true or false. So let me show you what I am saying. So we can check, okay, till which part we will get the strictly increasing part. So I am initializing my I to 1 and n is the num size. So we will continue our iteration until I is less than n and nums of I minus 1 is less than nums of I. That means we are checking for the strictly increasing part. So we are doing I plus plus. Now till what index we will get the strictly increasing part? Obviously I is the index till where we find that, okay, now it is not increasing. So obviously I minus 1 would be the index from which we can say, okay, till this part we will get the strictly increasing part. So this is the increasing one, because we need to find two strictly increasing parts. So I am giving the name as inc1, inc1. So inc1 will denote till which index we will getting the first increasing part. So it is I minus 1. Now we are checking for the strictly decreasing part. So till which point we will get the strictly decreasing part. So we are marking it with dec or dec. So this is the index till where we will get the strictly decreasing part. Now we need to check for again strictly increasing part. So we are just checking till which index we can get the strictly increasing part. So inc2 will get us the index till where we will get the strictly increasing part. Now we will check the condition whether this strictly increasing, this strictly decreasing and again strictly increasing actually exist or not, because if they don't exist, the I pointer will never move ahead from any of the position, from here also, from here also, or from here also. So we can check whether this inc1 is not equal to 0, because if it is equal to 0, that means we didn't get the first increasing part, so it should be greater than 0, right? So we are checking this, and this dec should not be equal to inc1, because let's say inc1 is here. Now we need to find the strictly decreasing part. Now if the dec is also here only, so that means we didn't get any strictly decreasing part. It should be greater than this inc1. It should be greater than this inc1, right? So then only we will get the strictly decreasing part. So whether this dec is not equal to inc1 or not. Now the last condition is that again this inc2 should not be equal to dec, because if inc2 is here, that means we will not get the strictly increasing part. It should be somewhere greater than this dec, so then only we will get the strictly increasing part. Also we need to make sure that its index should be n-1, because if its index is not n-1, let's say we got the increasing part, decreasing part and increasing part. Now there are few more elements to check, then they can again go decreasing, right? So we want that this increasing should go up till n-1, so that we cannot have any further decreasing or increasing scenario. So this index should be going up till the end. So if all these scenarios exist, that means we have a pattern like this: strictly increasing, strictly decreasing and then strictly increasing. So this is the scenario. So if this is the case, then we need to return true. Otherwise, if any of the condition fails from this part, then we need to return false, because it will not fulfill the condition of trionic array. So this is what we are doing, and we are doing it in single pass. So the time complexity will be O of n. So this is how we'll be solving this problem. So I hope you understand this solution. Thank you for watching.